The night sky is full of stars, galaxies, planets, and asteroids.
Asteroid actually means star-like. Even in the very best telescopes, they look like nothing more than just points of light in the sky.
They're cosmic boulders, and there are trillions of them. From the size of a car to giants hundreds of miles across. Together, they tell the story of how we came to be. The Earth was made by asteroids. Four and a half billion years ago, the solar system is a vast cosmic whirlpool. Dust sticks together to create asteroids.
In our own solar system and in every solar system, the first objects to form, the first large rocks before planets form, are essentially asteroids.
There are no planets yet. Instead, trillions of rocks and stones swirl around the newly born sun.
It would have been a very strange place, kind of like a merry-go-round of all these objects orbiting around the sun. And there are millions of these asteroids that are just in different sizes and different shapes.
These ancient asteroids will shape the solar system and build the planet we live on.
Asteroids are so much more than just rocks in space. They're the building blocks of our very own planet.
Billions of small asteroids must clump together to make a planet. But asteroids move at thousands of miles per hour. Getting them to stick is hard.
We're here at this stock car race. See what the early solar system may have looked like.
High-speed car collisions cause damage. Parts smash off. Asteroid collisions are the same. To join together, somehow they must collide and stick. Stock cars show how this happens. They move fast, but all in the same direction. Just like the asteroids in the early solar system. When collisions happen, they're relatively gentle. Instead of smashing apart, they join together. These are planets in the making.
They're going around almost at the same speed, and they begin to stick together, and that's how planets begin to form.
Asteroids gather into rock piles, like two cars locked together. As more asteroids collide, the rock piles grow. Building whole planets this way would take billions of years. Yet the planets formed in just a few million years. How? When the rock piles reach mountain size, gravity speeds up the process.
Gravity started to become important when they were about the size of one of the Rocky Mountains, like Pikes Peak behind me. It was when they were several miles across that they had enough mass that their gravity could start to draw material in. Now, if the Earth weren't here, and it were just Pikes Peak over there a few miles away, I would very slowly start to drift toward it, faster and faster, accelerating the whole way, until I actually impacted it. The gravity would draw me in, it would pull on me, until I actually hit the mountain itself.
Large asteroids are mountains in space. The early solar system is full of them. Their gravity pulls other asteroids toward them. The larger an asteroid becomes, the more rocks it pulls in, and the faster it grows.
At that point, the events happened very quickly. It would actually draw that stuff in and grow very rapidly.
One of these early space mountains keeps on growing until there are no rocks left to pull in. It's no longer an asteroid. It's a young planet, the Earth.
All of the planets, even the Earth, they owe their existence to the fact that there were asteroids back then.
This is how all rocky planets form. Asteroids join together until there are no more left. Mercury, Venus, Earth, and Mars are all overgrown asteroids. But beyond Mars, something went wrong. No rocky planets. Instead, billions of rocks and boulders that never join together. The asteroid belt. Out here, construction came to a halt before a rocky planet could form. Because of Jupiter, the gas giant had already formed nearby.
Jupiter is humongous. It's the 800-pound gorilla. It dominates everything gravitationally.
4.5 billion years ago, Jupiter's gravity causes havoc. It flings asteroids in every direction. Giant boulders scatter from their regular orbits onto extreme, chaotic paths. The stock car race ends, and the demolition derby begins.
Once Jupiter got involved, the solar system began to look like a demolition derby. Things colliding with each other, going in all sorts of different directions.
A cosmic pileup. Rocks smash into each other from every direction. Violent, chaotic collisions. These rocks don't clump together. They shatter and create the asteroid belt. Violent collisions still rock the asteroid belt today. In 2010, the Hubble Space Telescope captured this: the aftermath of a hypervelocity collision. Asteroids can both create and destroy. If many of them come together gently, you get planets. Too much violence, and you get the asteroid belt. Billions of rocks and boulders, a graveyard for a planet that never formed. The asteroid belt is a mysterious realm, full of danger and full of promise. A new frontier just waiting to be explored. Asteroids are as diverse as planets or moons. Some are metallic, some rocky, some icy. Some even have their own moons. They come in all shapes and sizes. From boulders all the way to miniature worlds. And they're everywhere. Distant solar systems have their own asteroid belts. The star Epsilon Eridani is just 10 light years away. It has not one, but 2 asteroid belts. Another star has a belt 25 times larger than our own.
If you were actually living on a planet in that solar system, the asteroid belt would look like a much brighter than the Milky Way, a big streak across the night sky.
Asteroid belts are the scraps left over after planets have formed. so they tell us a lot about their solar system. Our asteroid belt is full of variety. Millions of strange asteroids, each with a story to tell. Yet we have barely explored it at all. That's about to change. The first mission to the asteroid belt is underway. The Dawn probe. Its goal? To explore a mysterious, distant realm.
We're going to learn more about the main belt asteroids from this one mission than we will have since we've discovered the asteroid belt in the first place.
In July 2011, Dawn arrived at its first target and sent back these pictures. Vesta is the second largest asteroid in the belt. It almost became a planet. Then Jupiter's massive gravity stunted its growth. Today, it's a miniature world.
One of the common misconceptions about the asteroid belt is that things are fairly small. But some of the largest asteroids are really more correctly thought of as minor planets. They're several hundred miles across.
Vesta even has a mountain 3 times higher than Everest. Mark Sykes is co-investigator of the mission.
It's just a real excitement because you're seeing a new world for the first time, and you know just enough to be dangerous in trying to explain what it is that you're seeing.
Vesta is like a snapshot of the infant Earth, when it was just as wide as Arizona.
We're seeing perhaps what an embryonic early terrestrial planet like Earth looked like in the first few million years of its history.
The Dawn probe has already found that Vesta has an iron core like the Earth. Evidence that the Earth's core formed when the planet was still young. This stunted world offers us a window on the Earth's distant past.
We're seeing things that we didn't necessarily expect, but that's what makes it fun.
After Vesta, the Dawn mission will head into the asteroid belt's outer reaches to explore an icy, primeval world, 4 times bigger than Vesta. There, Dawn aims to settle another mystery about the Earth's past. Where did our oceans come from? The asteroid belt is ancient, violent, and remote. Hundreds of millions of miles from Earth. But not all asteroids stay in the asteroid belt. They can roam all over the solar system. The moon's surface records a violent past, a massive cosmic bombardment.
We see evidence every night when the moon comes out. What do we see? A pockmarked, barren world. Evidence that there was an intense rain of asteroids and debris that came from outer space, completely disfiguring the surface of the moon.
Millions of craters cover the moon, including the largest in the solar system, 1,500 miles across. Itself scarred by thousands of smaller craters. A storm of asteroids blasted the moon 4 billion years ago. And if that happened to the moon, it must also have happened to Earth.
The Earth is a much bigger, more massive target in space. For every one of those craters you see on the moon, you've got to imagine 50 or 60 craters here on the planet Earth.
The impacts back then must have been horrendous. Every few weeks, a gigantic object hurtling from outer space, gouging out a huge chunk of the planet Earth.
We call it the Late Heavy Bombardment. For 200 million years, fireballs rain from the sky. The impacts trigger earthquakes bigger than any in recorded history. 10,000-mile-per-hour hurricanes rip through Earth's primitive atmosphere. But asteroids also bring a new substance to Earth. Some asteroids contain ice, frozen water that melts on impact. Each asteroid brings a little more. But could asteroids really bring enough water to cover 2/3 of our planet?
One of the questions we have is, how did water get to the Earth? Because the original Earth, we think, was very hot and very dry.
NASA's Dawn probe aims to find out. The asteroid belt still contains icy asteroids to this day, in the coldest, most distant part. In 2015, Dawn will arrive at the solar system's largest asteroid, Ceres.
Ceres is 1/3 the mass of the entire asteroid belt and 4 times as large as any other known asteroid.
A lot of it looks like pure ice.
Ceres has a rocky interior and ice-rich mantle. It's far enough away from the sun, it's cold enough that it's stable.
Ceres is just 600 miles wide, yet there may be more frozen water here than all the fresh water on Earth. The Dawn mission will find out for sure. If Ceres really does hold so much ice, it could help explain why the Earth has so much water. When asteroids bombarded the Earth 4 billion years ago, massive icy bodies like Ceres could have brought vast amounts of water.
Water itself, in the form of ice, came down from the heavens to create the lush oceans of the Earth.
And not just the oceans. Clouds, rivers, glaciers may all have come from space. The Dawn mission may uncover something even more significant on Ceres. It may find an ocean underneath the ice, an inner mantle of liquid water, melted by heat from the dwarf planet's core. Life as we know it depends on water. Wherever we find water, we may find the spark of life.
If there is a liquid water ocean underneath the surface today, that begs the question of whether there could be life there.
Extraterrestrial life could have started in the asteroid belt. Ceres could be home to basic life forms, flourishing in a subsurface ocean. If asteroids like Ceres can support life, that could reveal how life started on Earth. 4 billion years ago, asteroids bombarded the young Earth. They brought water, and they may have brought life. From the asteroid belt to Earth's new oceans, primitive organisms that thrived and ultimately evolved into all the Earth's creatures. A planet that brims with life. Our earliest ancestors may have arrived from the asteroid belt.
Perhaps these little worlds could be incubators of life throughout our solar system, maybe even in other solar systems around other stars.
Asteroids may bring life to worlds throughout the universe. They may also bring death. Asteroids are crucial to life in the universe. But once life gets started, asteroids can also end it.
Asteroids really have two sides to them. They're sort of creation and destruction all wrapped up together.
Planet Earth is right in the firing line.
We've come to realize in recent years that we live in this kind of a cosmic shooting gallery.
Astronauts witness this firsthand.
When I flew on Apollo 9 and I went outside the spacecraft, it's very likely that I was hit by, a very, very small asteroid. And, it will make a hole in a spacesuit.
Most objects in the Earth's vicinity are tiny, but they move at thousands of miles per hour.
So the suits are very, very well built, the result of which is they're very heavy. But, we've never had one penetrated yet.
The Earth, too, has built-in protection from small asteroids. The atmosphere. When asteroids hit the atmosphere, they burn.
I can remember one night when we were looking down at the dark Earth, and I kept thinking I saw an occasional flash of light, but I wasn't sure. And then suddenly we're realizing, of course, we're looking at shooting stars.
Most people don't realize that on a given night, if you lie in the grass and look up at the night sky, you'll see shooting stars, many of them each hour.
Most shooting stars are the size of grains of sand. These burn up. But larger space rocks can punch right through to the ground. Here's the proof. Meteor Crater in Arizona, gouged out by an asteroid just 150 feet across.
You can see the huge force that excavated this, and you can also see the layers of material that were turned over as the crater was excavated. And so some of these rocks around here are kind of upside down from where they started.
There have been millions of impacts like this in Earth's past. There will be more. Imagine a city where Meteor Crater is now.
You'd see a fireball coming through the sky very quickly. This thing is moving at 8 miles a second, and so it wouldn't take very long for it to move across the sky and strike the ground.
Heat from the fireball scorches the surface, but most damage comes after the impact.
Once it strikes the ground, this takes a few seconds to create. So very short time, very large amount of energy, and very devastating effects.
The asteroid is obliterated. A mighty shock wave generates winds 6 times more powerful than a hurricane.
You have the blast that comes out, probably for several miles, and large debris that would crush buildings and homes.
If it hit today, the asteroid from Meteor Crater would be a city killer. But the Meteor Crater asteroid was small. It was likely a fragment from a much larger asteroid.
Whatever it is that hit in Meteor Crater wasn't very big. It was probably 50 yards across, so not even as big as a football field.
There are millions of much larger asteroids. These would cause even more carnage. Country killers, and worse. Asteroids over a half-mile wide could end our civilization. Worldwide killers. We know because it happened already. There are traces everywhere.
There's evidence of giant impacts all over the world, and it's right underneath your feet. And in fact, in some places, it's pretty easy to spot.
Like here in southern Colorado.
So this layer of light-colored rock, that's the KT boundary. And it's called a boundary because it marks the boundary between two different time periods. Everything that was put down here underneath the KT boundary had dinosaurs in it. Everything above it, no dinosaurs. So it really marks that point in time when the dinosaurs went away.
The layer is rich in an element called iridium. It's rare on the Earth's surface, but common in asteroids.
So if a giant asteroid came in, smacked into the Earth, blew out dust everywhere, the iridium inside the asteroid would have settled down into a layer all over the Earth. And that's exactly what we see right here.
The clear fingerprint of an asteroid.
There must have been some perfect morning before the asteroid impact when the land of the dinosaurs was still very much as it had been for millions of years. Then there would be something sighted up in the sky, something very bright, very hot.
The asteroid is 6 miles long, big enough to devastate the planet.
The asteroid that came in and formed this layer here was very massive and was moving very fast. And so when it impacted the Earth, that energy was turned into boom, very, very big boom.
It has the force of 5 billion Hiroshima bombs. Large pieces of Earth blow out into space, then rain back down, a storm of fireballs. Wildfires rage across the globe.
In the KT boundary layer is a layer of soot. And that's an indication that there were global fires, that everything on Earth was basically on fire after this happened.
The Earth plunges into darkness. An impact winter. Mass extinction.
Basically, you can think of this as every environmental catastrophe all happening at the same time. It was an incredibly bad day for planet Earth.
A chilling reminder of the threat from space. Asteroids this big will hit us again.
We will go the way of the dinosaurs. We will be survived, most likely by the bugs, the cockroaches. They will be the ones who will inherit this Earth. But hopefully, that's going to be a long time from now.
Is mankind doomed? Or can we dodge fate? Asteroids built our world. They brought water. They killed the dinosaurs and made room for new species. But asteroids are also a threat.
We know absolutely for certain that there will be large impacts in the future. So it's not a question of if, it's only a question of when.
Large meteor impacts happen once every 60 to 100 million years. We're due for one soon, perhaps.
If we want to survive, we need to prepare. We must find the asteroids, determine if they're heading for Earth, then stop them That's not easy, but it may be possible.
Happily, there's a difference between us and dinosaurs. We have telescopes, and we can get advance notice of an impact.
Asteroids are much smaller than stars and planets. It's hard to see them coming. To track asteroids, you need a giant telescope. Like the Arecibo Observatory in Puerto Rico.
Right now, I'm on top of the largest telescope in the world, and this place may actually be our best defense against getting hit by one of these near-Earth asteroids.
The vast bowl is 1,000 feet across. And it's not only the world's biggest telescope, it's also the world's biggest radar dish.
When you think about using radar to keep track of all the airplanes that are up in the sky, well, this one is so powerful, it can actually track near-Earth objects millions of miles away.
Unlike a telescope, radar can directly measure an object's distance and reveal exactly where it is. That's perfect for tracking asteroids. In 2004, astronomers spot a stadium-sized asteroid heading toward Earth. Its name, Apophis, after the Egyptian god of destruction. The day it might hit us, April 13th, 2029. Friday the 13th.
Apophis was the first near-Earth object of the modern era that had astronomers honestly scared. There seemed to be a 1 in 30 chance of something catastrophic happening.
Arecibo springs into action against the biggest threat from space ever detected. Apophis could devastate entire countries. But the asteroid's path is still uncertain. It might hit, or it might just miss. Only Arecibo can tell us for sure.
The Arecibo telescope was able to reduce the uncertainty of Apophis by 98%. It told us that there was no chance this thing would hit us in 2029.
It will be close. Apophis will pass closer to the Earth than the Moon. Closer even than some communications satellites. We have powerful tools to detect asteroids. Someday, we'll find one that will hit the Earth. How can we protect ourselves? The obvious strategy is to destroy the asteroid before it destroys us. But that could be risky.
You don't want to blow it up because you may end up breaking it into 2 or 3 or 5 pieces, which then end up hitting all around the Earth and wiping out many, many people.
Exploding an asteroid could cause more harm than good. Better to make it miss completely. When an asteroid is headed for Earth, their future paths cross. And they'll both reach that point at the same time. Imagine the Earth is a freight train, and the asteroid is a car, both heading for a railroad crossing. If they reach that crossing at the same time, they will collide. The best way to avoid the impact is not to swerve away from the train. It's to hit the gas or the brakes.
If you can cross the tracks before the train gets there, or wait for the train to pass and then cross them, that's what we want to do with asteroids, just to make sure that the asteroid and the Earth aren't at the same place at the same time.
By simply slowing down the car, we're going to miss. That's the way to avert a collision.
But asteroids don't come with brakes. We need another way to change their speed. One approach is to use the asteroid's gravity.
For a small enough asteroid, all you need to do is park a large spacecraft next to the asteroid.
A spaceship would hover above the asteroid's surface.
You can thrust with your spacecraft to keep it from falling onto the surface of the asteroid. And so it's like a little gravity tractor, using gravity as the tow line to move the asteroid out of the way.
Over time, the gravity between them would slow down the asteroid just enough for it to miss the Earth. Asteroids could shape our future in another way. We could turn them from a deadly threat into a precious resource. Asteroids are a creative force. They build planets. They bring water. But they're also destructive.
Asteroids are both a boon and a threat. Early on, they bring the materials for life. Later on, they can destroy life.
Asteroids bring violence and death. But life may not always be in danger.
Ultimately, if life becomes intelligent enough, it can send objects out to deflect or destroy the impending asteroids.
We now have the technology to divert asteroids. That means we can treat them not as a threat, but an opportunity. We could mine them.
Many of them are just ripe for the taking in these wonderful mineral resources. And so the asteroids in some ways are literally gold mines in the sky.
They're not just gold mines. They're zinc mines, aluminum mines, platinum mines. Just one average-sized asteroid could contain minerals worth thousands of billions of dollars. But first, we have to reach the asteroids. On April 15th, 2010, President Obama announced a new plan.
By 2025, we expect new spacecraft designed for long journeys to allow us to begin the first ever crewed missions beyond the moon into deep space. We'll start by sending astronauts to an asteroid for the first time in history.
Ironically, the easiest asteroids to reach are the same ones that threaten the Earth. As they pass by, a spaceship could rendezvous with the asteroid. Yet even when asteroids come so close, asteroid mining may be too good to be true.
The reason why we're not mining the asteroid belt today and letting the space program pay for itself is because of cost. It takes an enormous amount of rocket fuel and expertise to bring back an asteroid from outer space.
But perhaps we don't need to bring the minerals back to Earth. We could use the resources of asteroids to build settlements out in space.
You don't have to build a space station, it's already there. You don't need shielding because you can simply drill right into the soil and use the rocky material as shielding against radiation and micrometeorites. So in some sense, think of an asteroid as a ready-made space station.
Low gravity makes it easy to come and go. There's plenty of water and all the construction materials that colonizers could ever need.
So one day when we have colonies in the asteroid belt and we need to build cities there, that's where we're going to find valuable deposits of metals in the asteroid belt itself.
A vast band of cities in space, strung across 1 billion miles. And not just cities, but factories, to turn metal from the asteroids into spaceships.
Perhaps asteroids could actually provide the metal, the real structure to build our spacecraft. So somewhere up there between Mars and Jupiter, there may be the makings of our future spaceships.
Ultimately, asteroids may be a stepping stone by which we can one day leave the entire solar system.
Asteroids made the Earth. Perhaps they even brought life here. And in the future, asteroids could help humans escape the Earth and colonize the galaxy.
So in a way, asteroids are drawing us out into space, whether to protect ourselves or to expand where we live.
Advanced civilizations all over the universe may use asteroids as stepping stones to the stars. Mankind may soon enter the age of asteroids.